Oh, hi there. Thanks for showing up for your learning. It's Mr. Jennings, and we are looking at this idea of, let me call it up. Oh my goodness. Algebraic expressions. So these skills are a gateway to so many important ideas that you're going to be using for a lot of math courses going forward. It's where the alphabet starts showing up in your math problems. And it will rely on your skills with rational numbers and particularly integer operations. So we want to be solid on those. And it's not that hard. I will talk you through it. You will come to understand how to evaluate expressions today. Combining like terms is not so bad. Distributive property, I'll give you some metaphors to think about those and what it means to distribute a negative into a bracket. And then our top level skill here, this is a level 4 skill that I think everyone can get. This is simplifying expressions with distribution. So there's a big chance to develop your mathematical muscles today. So let's go. Let's get started. So our first skill that we have is evaluating expressions. Let me give you a new one here. So let's say we have a problem like this, and we want to know what's the value of this expression when x equals 5. Okay. So here's how we read these types of things and what they're meaning. I'm first going to go ahead and copy the problem down somewhere. 4x minus 8. Okay, and then I'm given this extra piece of information, x equals 5. All that means is wherever you see x in your expression, you go ahead and put 5. So we're just going to put 5 there. I can use the equal sign. 4 multiplied by 5 now minus 8. All right, now we evaluate with Bedmas. So I do the multiplication first, 20 minus 8. Now I do the subtraction, 12. 12 is our answer. So I go over here and I put in 12. Hooray! Okay, let's go. New problem. Oh, wow, this one is a little different. Let's see. How is it different, Mr. Jennings? Please show us. Well, I start, like any problem, by copying it out. 4y plus 9z. But I know these pieces of information. Y equals 5 because the question said so. Z equals 4 because the question said so. Now, wherever I have y, I put 5. Wherever I have z, I put 4. Okay, and I just evaluate. 4 times 20 plus 9 times 4. Evaluate. 4 times 20 is 80. 9 times 4 is 36. So this adds together to 116. Oh, what did I do? I see what I did. I did not put 5. I put 20. You see what I do? This is something I do sometimes when I'm doing math and I'm talking about it, is I evaluated 4 times 5 and then put 20 there. So sometimes we make errors. And then what should we do about it? We should laugh. Okay, so the correct answer will, of course, be 56. There it is, 56. Okay, should we do another? Of course we should. Of course we should do more. And if I hear you laughing in class, about math, and that's fine. That's great. I love it. Okay, here, let's take a look at these ones. Are going to be the most challenging problem types like this in here, and they're just Bedmas problems. Okay, and this is really important for grade 10, being able to work with equations that look like that. Okay, so I copy it out. 6 multiplied by y squared plus 8y minus 9. See how I copy it out? That actually helps me build my understanding. I also know y equals 2. Okay, so I'm going to do the substitution in another color to help us out here. Y equals 2, and I'm going to substitute that everywhere. All right, so I'm going to have 2 there and 2 there. And the rest of the places, well, I'm just going to have 6 2y squared plus 8 times 2 minus 9. The rest of the stuff just comes down. Okay, now I have to do Bedmas. So the first thing you'll notice I need to do here is the exponent. Let's go ahead and do that exponent first. Let's put me over the time so you don't know how much time I'm spending to help you out with your math. Okay, 2 squared. I better do that first. 2 squared is 2 times 2, so that's 4. Okay, plus 8 times 2. Sure, let's do it. 16. Okay, minus 9. Okay, 16 minus 9, we can do that. That's 7. Okay, 6 times 4, we can do that. That's 24. Okay, and then 24 plus 7, that's 31. Hooray. Okay, let's do another one like that before we move on. Okay, so we have y squared plus 4y plus 3. If you can do these mental math puzzles, that's amazing. Y squared plus 4y plus 3, and y equals 7. Okay, so we're going to have 7, put it in brackets. Always substitute into brackets when you're doing this. 7 squared plus 4, substitute into brackets, 7 plus 3. All that just comes down. We've done our substitution. Y equals 7. Hooray. And now we evaluate. 7 squared is 49. I can do this multiplication because it's separated by addition from other stuff. It's not going to influence things. 4 times 7 is 28, and then plus 3. All right, now I add all that together. And I spotted an easy way to do this addition in my head. These two add to 31, and the 1 will carry into that 49. So I do 49 plus 31 is the same thing as like 50 plus 30 is 80. Okay, but you can do that on a calculator if you don't spot those things. I spot them because I do them in my head. So my head notices the quickest way to do stuff. Well, it's quick for me. Okay, so that is evaluation of expressions. We are learning to substitute in and then do the arithmetic to evaluate what that looks like. Next, we're going to take a look at the next topic, which is combining like terms. Combining like terms is just adding all of the different stuff together. So let's see what problem types we have here. Let's start with these. So we want to know which expression is equivalent to this. Okay, here's how you think about it. Here's how I want you to think about it. If we have something like, copy it out, minus 3w plus 9 plus 7w minus 3, okay? W is some number we don't know yet. That's all W is. And you can think about W like a watermelon, okay? And just numbers as like dollars, okay? So this would be like minus 3 W's, minus 3 watermelons plus 7 watermelons. How many watermelons in total? Well, we can actually rewrite this. And this is a nice way to rewrite it, is just say 7W minus 3W. So I'm just going to move this one up here. This one can move down there. And then this one can come down here, plus 9 minus 3. And what I've done is I've reorganized all those terms where the like terms are together. Watermelons are with watermelons and dollars are with dollars. So that leaves me with 4W plus 9 minus 3, 6. 7 watermelons, and then you take away 3 watermelons. Where are you going with my watermelons? I only have 4 left. You can all visualize that. Visualize 7 watermelons on the picnic table, and I come by and I take 3 at once, like I'm laden with watermelons, and I run away, leaving you only 4. Like, absolutely visualize these things, and it's very easy. Okay, so then I just choose the correct answer, submit. Hooray, new one. Yeah, we'll get there. Okay, let's do x plus bx plus cx like this. Okay, which expression is equal to u minus 9u? Okay, u minus 9u. Okay, well, we can copy it out. Well, that's a y. U minus 9u. Okay, so I've got a u, and then someone takes it away. So u minus u, that's just 0 minus 9u. Okay, and if I have 0 of something and you take away 9 of those things, I must have negative 9u. Okay, so these ones, they do go across the, like, if I start up here with like 5 of something and you take away 10, I go down to negative 5, right? That's negative 5. That's subtract 10 from 5. So we can still have negative numbers down here. Use just a number we don't know yet, but whatever value I put in there for you will be the same as here. So this one would be correct. All right. Now, there are some more challenging problems in here, like, say, the perimeter of a rectangle. Okay, let's check out these ones. The width of a rectangle measures 3b plus 5 centimeters, and its length measures 8b plus 6. This one, we're getting into some connections with our 2D measurements next. So you're getting practice on multiple scales. Isn't that fantastic? So draw these. Okay. And so I say, well, here is the width of the rectangle. It's 3b plus 5. And then here's the length, 8b plus 6. I don't know b, but I do know that these would be the lengths and the widths. But because that's the same as that, this is also 8b plus 6. And this is the same as this because we're a rectangle. So 3b plus 5 is also over there. That's a rectangle now. Doesn't matter what value of b I put in there, I'll still get a rectangle, unless I put in weird negative values that create negative side lengths. Okay, so now I want to know the perimeter in centimeters of the rectangle. So the perimeter is going to be all the sides added together. That's the definition of this word perimeter. So you can imagine a little ant. Starts here. Okay, there's my ant. And it walks all the way around. How far does the ant walk? That's perimeter. Okay, that's what I want you to visualize when you're thinking about perimeter. Okay, there. So the perimeter is going to be 3b plus 5 plus 3b plus 5 plus 8b plus 6 plus 8b plus 6. Okay? And now I can reorganize that in a nicer way. So I could say this is 3b plus 3b plus 8b plus 8b. And all those b's, those are just like bananas. 3 bananas plus 3 bananas plus 8 bananas plus 8 bananas is 22 bananas. But then I've got all my b's. Now I need to get my numbers. So it's plus 5, plus 5. And you can draw arrows, or you can do this, plus 6, just to make sure you get all of them down there on the next line. Okay, don't forget a term because that would mean you're making a mistake. And then 3b plus 3b is 6. 8b plus 8b is 16. 6 plus 16 is 22b. Okay, that's what all of these bananas add together to give you. And then 5 plus 5 plus 6 plus 6. Oh, that's also 22. Cool. But it's not 22b, it's just 22. See, because that's just the number 5. So it adds together to make just numbers. We don't need any letters there. All right. So let's write that 22 plus 22b. Also notice I had 22b plus 22, but that is the same thing as 22 plus 22b. We can move those around just so long as the signs follow the numbers. The signs always must follow. Okay, let's do another one. Let's try a triangle. This way. Okay, let's try this one. All right, so draw it. I wish they had some negatives in there. Whatever. Okay, a triangle has side lengths of 4m plus 3n, 8m plus 10p, and 2p plus 2n. Cool. Which expression represents the perimeter in centimeters of the triangle? Well, the perimeter, again, is the distance around the whole sides. We add all the sides together. So that's going to be 4m plus 3n plus 2p plus 2n plus 8m plus 10p. Now, I want to, maybe I do this and I reorganize it a bit. I'm going to grab my m's first, m and p. So I'm going to grab them in alphabetical order just so I don't forget a whole thing. 4m comes down, 8m comes down. Then I'm going to grab my n's, plus 3n, plus 2n, plus 2p plus 10p. Now I can collect these. Those marshmallows plus marshmallows gives me 4 marshmallows plus 8 marshmallows is 12 marshmallows. 3 nuts plus 2 nuts is 5 nuts. And 2 papayas plus 10 papayas is 12 papayas. This is an N. This is an M. 12M plus 12p plus 5n, I found it there. Notice that it's not in the same order as mine. They're wrong, I'm right. No, we're both right. Mine's better because mine's in alphabetical order, so I like mine better, but theirs is still fine. That's still going to be correct. So that's how you collect like terms. That's really what we're doing, is all those things have to be like. Okay? Now, one thing that this is not getting into is, here's another situation. Let's say I have something like this, and this one, I'm going to actually go add it to this one here. But we want this skill in here. Here. All right. So with this skill, we are just adding and subtracting polynomials now. But in this case, here we go. In this case, we have like x's and x squareds and things like that. So let me give you another example here. Another one. Come on, give me one. You don't have one? You don't have one with me? Oh, that's fine. Whatever. Who cares? We'll do this. Okay. So same thing we do here is copy the question out. So I've got negative x squared minus 6x minus 3 plus negative 4x minus 7. Okay, so now I only have x's as my only variable, so like x-rays or something, whatever, you can still imagine it. But I also have times where the variable is being squared. Okay? We can combine these two, they're like terms. We can combine these two, they're like terms. This one ain't got no like terms. It's unique. Okay, it's an x squared. So that one can just come down, negative x squared, and then I could write minus 6x plus minus 4x, and then minus 3 plus minus 7. Plus minus 7 is the same thing as minus 7, right? We got some practice with that with integers, right? Okay, and now I combine. This one has no like terms, so it's just there all lonesome. Negative 6x minus 4x, well, that's a combined total of negative 10x. And negative 3, negative 7 is negative 10 also. So this is final answer, negative x. Use shift 6 to go up there, x squared minus 10x minus 10. Hooray. So that's how those are done. So all you need to know is that we are combining what's like, and for a term to be like, it has to have the same variable and also the same exponents. If the exponents are different, they're not like anymore. We're also going to be given ones like this, difference given expression with parentheses. So this connects to a skill called the distributive property, which we have a whole other video on down below, but these questions look like this. If I have 4x squared minus 6x plus 1, and I'm going to subtract from that minus 5x squared plus 8x plus 6, this is a preview of the skill I'll show you in just a minute. This negative means subtract that, and subtract that. All of them get subtracted. We are subtracting the whole bracket. So here's what I would do. I would say this is 4x squared minus 6x plus 1 minus 5x squared minus 8x minus 6. All of these signs, if they're positive, they go to negative, okay? All the positives go to negatives, but if they were negatives, they would go to positives. I'll show you another example. And then I collect them. 4x squared minus 5x squared is negative 1x squared. Negative 6x minus 8x is minus 14x. And plus 1 minus 6 is minus 5. So this is the final answer that Delta Math is looking for. So let's go ahead and give it to it. We're just going to do it this way. Okay, and move it so that you can see it around my face. Okay, minus x squared minus 14x minus 5. Hooray. Okay, let's do another one. No, I wanted different expression. No, not that one. Yeah, that one's okay. There's a particular, yeah, no. Come on. Give me one. Yeah, there we go. That's what I'm looking for. All right. So if you have a problem like this, 2x squared plus 10x minus 2 minus, so we have that in brackets. Shift that over. Negative 8x squared plus 7x plus 7. Okay, you all know me, and you all know that flicking light switches is one of my favorite things to do in math class. So this is a situation where we have like a negative and two positives inside the brackets, right? There's a negative 8x squared, a positive 7x, and a positive 7. I'm feeling like I'm losing some of you because I cramped that a bit. Okay, see how there's two things in there that are positive and one thing that's negative? But this says flick all those light switches. That is to say, nothing in there changes because this is like plus this thing. It's just positive that bracket. So I can bring that down. There's nothing in there that's a like term with itself. So that all just comes down. But then I do minus 8x squared. That's actually plus 8x squared. Minus positive 7x, that's minus 7x. And minus 7, that's minus 7. Okay, so basically what's happened is every sign inside the bracket flipped. See, they were there. Now all the signs have flipped. They've all changed. And that's all due to this minus. It subtracts everything inside the bracket. So now we can collect our like terms. 2x squared plus 8x squared is 10x squared. 10x minus 7x is plus 3x. And minus 2 minus 7 is minus 9. That's the answer Delta Math is looking for. That's the answer Delta Math will receive. Hooray. So that's that skill of adding and subtracting polynomials. Now, there's these questions in here that are a little challenging. Find the sum of this. All that's asking you to do is go from a sentence and write out your math sentence. So I want to take minus 6x squared minus 4 and sum or add it to 9x squared minus 7x. And then I'll get 3x squared minus 7x minus 4. Okay? So I could rewrite that as negative 6x squared plus 9x squared minus 7x minus 4. These are like terms. These are not like terms. So these can combine into 3x squared. Minus 7x minus 4. That's correct. And then we can also find these types of problems in here as well. Subtract that from that. Okay, so when we want to subtract something from another thing, we would say, well, I first start with what I'm subtracting from, 10x squared plus 3x plus 9, and I'm going to subtract from that negative 4x squared plus 7x minus 8. See how I wrote it out with brackets and it looks like just like some of those other problems that we've been working on? And so then I might have another line, 10x squared plus 3x, that's a plus 9. Then this flips that sign, plus 4x squared. This flips that sign, minus 7x. And this flips that sign, plus 8. Well, that's a good example. I like this one. Now I have these squares that are like terms. I should really say that plus is part of it. So that's 14x squareds. And then I have plus 3x minus 7x, so that leaves me minus 4x. And plus 9 plus 8 is plus 17. So that's the answer that Delta Math is looking for. This is finished. This is fully simplified because there's nothing else that can be done to it. It's there's no like terms that I can combine. If I told you what x is, then you could evaluate it. But actually, x could be any number of things. This is a mathematical phenomenon that you're going to be studying a lot in grade 10. Regardless of your stream, you want to understand quadratics. These are some of the most common relationships that we're going to see in the universe, so you want to understand them to understand the universe. All right, let's keep going. So our next topic is the distributive property. So let's take a look. I think I've got some space over here on my pages. Yeah, good. I'll work over there. So distributive property. Use the distributive property to write an equivalent expression. Here's how I want you to think about the distributive property. M's can still be marshmallows and N's can still be, I want something better than what I was saying before. N's can be, oh my gosh. Sheesh. 5 times 10 marshmallows plus 4. Oh my gosh. Okay, if you were worried about me that my brain was breaking, it was breaking because I couldn't think of like a food that started with N that wasn't nuts. And I've come up with Nutella. I was thinking nougat. I couldn't think past nougat, but we're going to go with noodles. Okay, N are noodles. Okay, so we've got 5 times 10 marshmallows plus 4 noodles minus 2. Okay, so think of this as 5 boxes. Okay, and I'm going to draw a picture for us here. So we got 5 boxes. 1, 2, 3, 4, 5 boxes. Inside each box is 10 marshmallows, 4 noodle packages inside each box, right? We got 10 marshmallows and 4 nougat packages, noodle packages in each box. I'm so sorry, my brain is so broken. 4 noodles, 10 marshmallows, and 4 noodles. And maybe inside each one there's negative $2. I don't know what that means. You don't know what that means, but any case, maybe it's like a coupon or something, or like a IOU note. Who cares? All right. But there's that many things inside each box. So let's say, what is this equal to? Well, if I want to know what this is equal to, I would just count them up. That's 10 marshmallows plus 10 marshmallows, 20 marshmallows, 30 marshmallows, 40 marshmallows, 50 marshmallows. Okay. There's 50 marshmallows in there. 4 noodles, 8 noodles, 12 noodles, 16 noodles, 20 noodles. -2, -4, -6, -8, -10. Okay, so that's what this is equivalent to. Now, I want to ask you, do you want to draw boxes every time? Probably not. Okay, so here's how you do it algebraically and efficiently on your page. You say, you understand that this is a thing and this is a thing, and we are multiplying those two things. That's all this means. That's all we're doing. So it's going to be 5 times the first part of that thing. That's 5 times 10 is 50 marshmallows. And then we do 5 times 4 noodles is 20 noodles. And 5 times -2 is -10. Okay, so same thing without visualizing boxes. But you can always visualize boxes. The brackets are like boxes. It's really cool. Okay, so now we know, and so we write her in. 50 marshmallows plus 20 noodles minus 10. 50 marshmallows up 20 noodles equals 10. Okay, these are all really similar. That's distributive property. Let's do one more example. Just one like this. Okay, 2 times r plus 7. Okay, so this could be like saying 2 times, there's rice in the box, plus 7 grapes. I know there's not a little g there, but there could be, okay? 2 times that plus 2 times that. So this is 2 rice plus 14 grapes. 2 times r plus 14. That's your just basic distributive property. That's like a level 3 skill on our learning map. Fantastic. We also want to know how to distribute a negative. I told you there was a video just only on this topic, so let's take a look. If we have something looking like this, write an equivalent expression by distributing the negative sign outside the parentheses. This works the same way, okay? The same way as what I just showed you. Negative 8.5w minus 4x minus 7, okay? This negative comes in and multiplies both of those things. Multiplying by a negative basically just flips the sign. So this was negative, both flip to positive. 8.5w plus 4x minus 7. You see, this one was not inside the bracket. So it does not come along for the multiplication by -1 ride. So that's the answer that Delta Math is looking for. Okay, let's see what else we've got. Well, let's try this. Okay. This one, I just flipped the signs. Watch what I do. Negative 8k minus 0. That's 0.4. Oh no. Oh no. Minus there. 0.4. That was an unfortunate typo. M plus 9.5. See how I just flipped every sign in that bracket? That's all I need to do. If you don't need to write it out, don't write it out. Just do it. Okay, so that's how you distribute a negative. Very quick skill, but very important. And so often students are going to get that wrong. Finally, we get to our level 4 skill for this whole expectation. And if you're saying, this isn't that bad, I can do this, and I can get the level 4, then I salute you and your mathematical confidence. So let's go ahead and get her done. Simplifying expressions with distribution. This is just like simplifying and put the distributive property and do it with bedmas, okay? Do your multiplication first and then your addition and subtraction. So I rewrite, that's good advice, rewrite. Okay, so I rewrite the question. 6 multiplied by 8f plus 18, what the heck? Plus 10g plus 9g minus 4. Do I have space over there? I do. Times 3g plus 9f. Okay, let's go. Let's do it. All right, so we're going to distribute. I have 6 of these boxes. Inside each box is 8 pieces of fudge. So 6 boxes, each with 8 fudges. That's 6 times 8, which is 48 fudge. 6 times 10 grapes is 60 grapes. And then I just have plus 9 grapes. That just comes down. And then minus 4. I'm going to subtract 3 grapes 4 times. So that's minus 12 grapes. Notice I had to bring the number and its sign. Minus 4 times 9, minus 36 fudges. Okay, now I can, that's equal. Now I can rewrite this. So I'm going to put my f's first. So that's 48f minus 36f. And then I've got plus 60g plus 9g minus 12g. Okay, I've got all my g's together, all my f's together. So 48 of something minus 36 of something leaves you 12 of that thing. 60 of something plus 9 of something minus 12 of something is the same thing as 57 of that thing. This is the right answer. And it's the simplest terms. It's like we've really simplified that whole big knot of algebra into 12f plus 57g. Hooray. Okay, let's look at harder examples, and then we'll call it a day with this video. All right, simplify the expression. What's in here for problem types? Okay, good, I love it. Okay, let's go. All right, let's do this one. Yeah. Oh my goodness, rational numbers made an appearance. Yeah, don't worry, they're just numbers. Times 4u, those could be oh gosh, what kind of food starts with u? I don't know, the post-it notes. Okay, it doesn't matter what they are, but there's 4 of them, plus 7 over 4u minus 3 plus 2u. Okay, so now I want to figure out how many u's there are and how many just numbers there are. So I notice here I actually have like terms inside the brackets there. So I could simplify that first, and that would be doing what's in the brackets first, and I would suggest doing that. So 4u plus 7 over 4u, here we need a common denominator. Anything that I'm not using right now, I just bring down. It just survives and stays the same, okay? But 4u is the same thing as 16 over 4u plus 7 over 4u. How did I know 4 was the same thing as 16 over 4? I did this rough work on the side in here. 4 times 4 over 4. Okay, 4 is just 4 over 1. And so that's 4 times 4 on top, or 16. 1 times 4 on the bottom, or 4. 16 quarters is the same thing as $4. 16 quarters is $4. So I didn't change anything. I just wrote it in a new way. Okay, 16 quarters plus 7 quarters gives us 23 quarters. So let's do that. Now, we've done everything we can inside the brackets. Like, I know there's still subtraction inside the brackets, but I can't do that because those are not like terms. So I just move past that. We just move on, folks. We just move on. We do this multiplication. Bian, bian, okay? Negative 5 is what I'm multiplying by. So negative 5 times 23 is negative 115 over 4u. And your calculator will tell you the same thing. Okay, negative 5 times negative 3 is plus 15 because negative times a negative is a positive. And then I still have plus 2u, but I'm going to write that as 8 over 4u because I see I need a common denominator here. Cool. And then negative 115 over 4 plus 8, well, that's the same thing as negative 107 over 4u plus 15. Done. Final answer. Put it in the box. Minus 107 over 4, don't you? Plus 15. Yeah. All right. So that's how those are done. That's how all those skills are done. You're welcome, everyone. I hope this was helpful for your mathematical learning journey. I look forward to seeing what you can do with these types of expressions and signing off on your high level skills and getting you ready for grade 10. All right, everyone. Any questions, absolutely hit me up by email, ask me in class, track me down in the hall, ask your own math teacher, ask your classmates, but don't struggle too long if you're missing some of these ideas. Struggling for about 30 seconds is good. Struggling for 5 minutes or more is frustration. So a little bit of struggle is okay. Bye for now.